All right. Hey, game devs. We're going to talk about classes. Basically, what a class is and how we use them, especially as it relates to game development. And the basic way to understand it is if we remember our thought process around like integers and floats, right? They are a box. And in that box goes a value. And this is maybe a Boolean box. And the way classes work are, kind of the same thing. We've got, instead of a single object that contains a single type of variable, we instead have something that might have integers, floats, and they might also have methods. So functions, class. So we can then allow we can now via programming put in and use a class, or excuse me, not use. We can access a class in code. And ask it to do something for us. Or ask it a question. Or perhaps change a variable. So if you think about a class for an enemy, we might have a string value, and that's name. What is the name of the enemy? We might also have an integer value for HP, and we might set that equal to 10 or something. We might also have experience points. Oops. We might also have in our, our character or our enemy class, we might also have things like a function that says function take hit. Oops. All right. So with this take hit function inside of the class, we can detail out everything that's going on. And it looks like I have someone texting. Okay. So all right, got that closed. So we've got this function, take hit. This may have a bunch of code which says like make a explosion or whatever. So the class will have a lot of information in it. But let's say that we don't really care about writing in every single thing. When we are in another piece of code, can't spell today. So when we're in a different code file, we can, instead of saying, so if this is class enemy, and this is all pseudocode, so it's not looking exactly like what it needs to look like for C# or whatever, but that's not, doesn't really matter. So we can actually access, we can say, hey, enemy dot, and remember the dot from accessing other classes in Unity, dot take hit. So this might be really useful. Let's say we have many, many enemies, right? So enemy take hit might be part of a piece of code that says, that says like if, maybe this is a bullet.cs. And we might say if collision col. So if a bullet collides with something, get its collider object, and then if it is an enemy, if it's got the enemy script here, it will run the take hit code for the specific enemy. So that way it doesn't make every enemy in the world take hit. Because, when we're working in code, oftentimes one line, this one line here, is way easier to write than all of this stuff over and over again. Not only is this bad, we do not want to write stuff over and over again. It makes for difficult allows for bugs. Okay, so a lot of times if we have duplicate code, we want code to do one thing and then other places to reference that one thing. So that way when we make bug fixes, it doesn't only work for certain possibilities. And, this is also better than get component, assign component, change component value. The way we teach you right at the beginning using get component, like that doesn't necessarily make a lot of efficient sense once we get into it. And that's one of the things about video game development in the kind of advanced scripting portion is we're actually kind of using a lot of the stuff you already know from intro to scripting. You're really just thinking about how do I make this efficient so that it doesn't overload the system and that kind of thing. So just checking my notes. So the other thing about classes, classes are awesome. So one of the values of classes is that we can instantiate classes. What I mean by that is when we say, we can say new enemy, and then maybe we plug in. So we have all this stuff here. We'll talk about how we plug it in later, but we've got name, HP, XP. Maybe this is the XP value of killing it. So we can create a new enemy. Whoops. So we might create a new variable called enemy A. If we remember our instantiation code, we'll create a holder for it. And then we'll say enemy A is equal to new, oops, handwriting could be better, new enemy. And then we might say the enemy's name is Strong Bad. And it's got 10 hit points. And it's worth 300 experience points. So we can create this, and again, pseudocode. It's not exactly the way it's going to look in C#, but this is just getting the point across. Everyone's given you syntax in some of the other videos. So you get this enemy A. You could also do this with enemy B. Oops. Pick a time. So slow. Okay, great, thanks. Enemy B equals the same junk here, except maybe it's strong sad, and then 1 and 0 or 10. Okay, so from here, now we've got in this hypothetical thing, in this hypothetical world, we have two enemies wandering about. One is called A and one is called B. And then when you say, and then you could apply like enemy A dot take hit. And maybe you're passing it a value of like 3 hit points. That you're, this is in the player script or the attack script, and this is how much damage it's giving. And then it'll run and execute that code for you, and it'll keep everything kind of nice and neat. So let's think about how this can also be valuable. So what we're talking about here is object-oriented programming, OOP. The basic rule of object-oriented programming is that single responsibility principle. And what it says is every class should handle one thing. All right. So what this means structurally, let's take, for example, our flying magical superhero game called Power Armor Person. All right, Power Armor Person. The game. All right, now Power Armor Person, the game, it's a side-scrolling platformer because that's all I make, side-scrolling platformers. And inside of it, we have the AI code. Now, originally, the way we worked, we had our AI is we had this big long script. It's over, it's 1,000 lines of code. It's really hard to debug, and we call it superenemy.cs. And in superenemy.cs, we have all our character types. We have a melee character, we have a flyer, we have a blocker, we have a magic user, and we have an archer. Okay, so we have 5 different kinds of AI. They all behave very differently from each other. And our original code is called superenemy.cs, and if you were to zoom way, way out, it might look, something like this, where we have like big chunks of code here, movement. And, imagine that this is code. And we might have like 30 variables in a big, huge list. We might have movement code here. We might have the magic user, and we might have ranged, etc. So so we have a bunch, we have a bunch of chunky, kind of difficult to handle code. If anything in here breaks, you have to go through everything. It's not very pleasant to deal with. So what we do instead is we can think about our code and our super enemy. How can we maybe break up this stuff so that it's in more usable chunks and that we don't replicate a bunch of information we don't need, and we can kind of limit what it is that we do need. So we've got melee, melee, we've got people on the ground, magic users, maybe they fly. We've got this fly and stand, and we've got this flyer, which maybe it's like a bat or something. So we have a couple things in here that we might have as a class. And then one of the nice things about classes is that they inherit from each other. That allows us to borrow certain amounts of code and build upon it. So every single one of these things is going to probably have an enemy.cs script. And inside this is going to be basic stuff like hit points, and like the transform, where is it? And maybe it is, got a name and a type. And maybe this is all the information. Oh, and then maybe there's some like animation state or something. Maybe there's a character controller. I won't write that there. But maybe there's a character controller on the main enemy.cs script. Because everything animates, it animates differently depending on where it's at. So from here, we've got this enemy state. The only thing it does is the basics of what every character does, or what every AI does. Now, we've got flying and magic users versus standing characters. So we might have movement scripts. And we might have two kinds. We might have ground and fly. And these would operate pretty differently from each other. And then we've also got, it looks like we've got two ranged attacked characters and then some, and three kind of other characters. The ground and fly stuff might have, so for instance, for flying, it might have like radius to player. You want to stay within a certain radius to the player and then like ease in and out. But maybe the magic user and the flyer have different kinds of radii, right? So in your much, much smaller enemy scripts, we got enemy flyer.cs. And this handles how flying works and attacking works, right? Whereas we might also have enemy magic user. Or perhaps we, these are even smaller because we can even break this down further into objects or types, melee.cs, and then ranged.cs. So there's a couple different ways we can organize this. But but what happens is that if we break it down, it becomes much more readable and you can fix things much faster. All right. So not only with cleanliness and legibility, it also helps with efficiencies. So like I was saying, when you instantiate a class, Creating everything out of one class is called the Singleton Pattern. It's something you'll be going over soon, and is part of thinking about how to create really efficient code. So instead of creating a bunch of different classes with with different code, you want to try to instantiate and then inherit everything so that enemy script. We'll go back up here. So enemy flyer is inherits from enemy CS, as these all do, as needed. All right, so why organize data? Why organize data like this? Well, at a certain point, other than the organization, it has to do with access modifiers. So let's think of a project. We've got my code. Over here, we've got plugin A. Plugin B. And each one of these has a bunch of classes. And these are accessible to everyone. Yeah. And accessibility is kind of the thing here that's going to be the important thing. That's why they're called access modifiers. It's something that you've played with already and maybe didn't understand all the way, or maybe you already do. But when we're working with access modifiers, what we were looking at is making sure that that visibility is what we're trying to figure out. So is it possible that code in plugin A can look at code in my code? Why, yes, it is. So what happens if you have a piece of code called player.cs, and then this other plugin also has something called player.cs? So these two files might collide, and that would be bad, right? So there's something called namespaces. And this is what Unity uses to allow us to create a namespace for plugin B and create a namespace for plugin for your code. But what happens is when this this hides stuff from other programs or from other namespaces. And then you have to, you have to expose them on your own. Okay, so there's uses for this in general. So let's get back to access modifiers, visibility. So we all know we've got like our update function, right? Update, and then inside of here we have a integer called int equals 5, or int health equals 5. All right. So if this is inside, the update function, and can only be visible in here generally. If we want health to operate inside the update function and in the take hit function. Bad handwriting. Health equal or minus equals 1, right? So every time we call take hit, it minuses 1 from the current health. So if we wanted to do this, we would have to make sure that health is declared inside of our code, inside our class, and we might call this a private. Oops. We might call this a private integer health. Now, this variable is visible to the script. Okay, but not everywhere else. Now, I've had you often call public int health. So perhaps there is other code and it says change player health. Instead of changing the player health inside of this file and then having like two places where player health can be, all it does is it might tell this file, hey, health, I want to change the health to this other thing. So we might change this to public. These are access modifiers. Private, public, and then there's one more. Static. So when we've got static int health, and I'm getting a little cramped here. Let me move it down a little. So static, this means all instances of the class have the same instance of class, have the same variable. Okay, so instead of, let's say, health, let's make this something more useful, visible. Maybe a Boolean called visible. So what we're saying is that every single thing that's derived from enemy is either visible or invisible, and right now it's true. So instead of changing up and let's say we have 100 enemies on screen, right? Instead of changing, we might command it turn enemies .cs off, right? Maybe we want to kill all the enemies in the game, or make them invisible or whatever. The way this would work, 100 changes to a list of things. All right, so you'd have to do this 100 times, whereas using a static variable, one call. So this is a very straightforward where like, hey, I just want to turn everything off and I want it to be more efficient. Because think about it, what happens if you like pushed that button and then it like took 3 or 4 frames and it kind of chugged because it was like, oh, I've got to unload all this stuff, and it would do that just all in the same frame. Perhaps it would be a little bit faster to just change a single static variable. All right. So let's talk about code efficiency. because it's all in the name of efficiency. I probably spelt that wrong. There's something in there. There's some letter, I-E-N. So there's three things to code that makes it efficient. One is the algorithm used to sort. So for instance, like a for loop just goes through every variable. But let's say it was like sorting a list of things or trying to find the name of a person. But maybe there is a first letter check, then second algorithm. So like it might look for if it's my name, instead of looking through every single, like maybe there's 1,000 entries. Instead of saying, does this one look, does list 397 equal Kenneth? Instead of doing this, it instead might say sort every letter, sort names by first letter. And then this might give me a list of 100 names. Start with K. And then even here, if I was to then sort through these 100 names with a for loop, it would be 1/10, maybe like, let's say it's another 1/10 worth of work just to sort all the first by the first letter or something like that. So, but we'd still have like 20%, 20% versus, or let's say 20 cycles of computer processing power versus, with 1,000, not 20, 200 versus 1,000. Okay, so the first thing is the algorithm to sort. That's part of efficiency. The second thing we do is the amount of local copying. / detection. So what do I mean by that? How do you reference variables? And change variables, I should say. And that's the power of classes. Is in changing variables back and forth. So instead of having a lot of code running the same kind of arguments, so every single enemy doesn't necessarily need to have every single piece of code in it to store and to access. It just needs the things that it needs. So the power classes allows you to kind of slim down everything and then reference one variable and change that specific one specifically with instantiation. So there is a third one, and this is something kind of out of control, but it's like the engine. How does the engine cache and garbage collect? That kind of stuff. It's not something that you're going to be able to control as much. All right, so that's all I want to talk about for classes. There is a lot to this. Make sure to go through everything, understand what you can, and ask questions in channel. Other than that, I will see you in class.